Welcome back, YouTube. This is the Death's Doorstep Devlog Part 3. Unlike previous weeks where I focus on a single topic about the kind of the baseline of how my game works and the engine I'm using works, I'm going to switch it up this week and just kind of focus on what I worked on this week and what I accomplished and what I'm going to start working on next week. So this week I focused on something I mentioned in the last week's Devlog. That is breaking down my standing state into two other states, aka standing, walking, and running, as well as ducking actually. And you'll be able to see that now it enters in the drone state. If you remember last week, drone state is the state where the player walks in and is controlled by another script, as opposed to standing where the player has control over his own destiny, I guess you could say. You can see walking is a state that I enter into, and it jumps back to standing when I let go. Same with ducking is its own state now. Walking and then running on top of that also has just been split out. So last week that all existed as just the standing state, and I was not a huge fan of that. I needed to break that down. So I'm going to show you a little bit of how that looks. Alright, so I have four scripts here. The first of which is root.cs, which if you remember from last week is the state machine, basically. So I have all my states defined here. As you can see, there's a definition for standing, walking, running, ducking, as well as jumping, sliding, a lot of other things I'm not going to focus on this week. The primary things that you have to look at are these four lines. I'm defining these four states. This used to be a single line, which was just define standing, but now it's been broken out. Besides that, this class hasn't really changed at all. So let's check out what my standing state now looks like. These are just shortcuts for different components that I want access to. You don't have to worry too much about that. It's just easier for me to read while I code. Up here we have the subscribe. So this is kind of where it's switched up. A lot of these events are more specific to the actual current state. So before they would trigger off some logic, which would be accelerate in the left direction, in this case of left held. Now it just enters into a separate state for walking and running where that logic is handled. So as you can see, it's basically built off of some common events like input, and then it jumps into other states. So in this case, if you attack, if you hold up while you attack, you'll do your up whip animation, or you'll just do the forward whip animation. Left held, if the run button's held, running state, or else go into the walking state. Like very, very simple things to get into different states. If you press jump, you jump. This is something that I'm not going to go into yet, though if you're curious about it after the video, at the end I'll try to mention it a little bit and describe how it works. And then on enabled, it just plays the correct animation. So you can kind of see how the flow here works. It's just when entering the state, play the correct animation. If you're off of a platform, then enter the jumping state. Besides that, it's just handling input events. Down held is just ducking. So you can see ducking is just a similar sort of setup where on enable, play the duck animation, do a little squish. I can show you what that is actually real quick. So it's just something that that makes the animation look a little bit more fluid. Just doing a little squish animation. That is actually like a single frame. It doesn't squish down like that in the actual animation file. Physics. So if you ever release the down button, enter standing, then jump pressed. So yeah, this is just to check to see if, because there's one-way platforms now, you can now jump down. If you have a floor, you're on a one-way platform, you can detach and jump downwards. Otherwise, you're just going to jump straight up. So moving on to the walking state. So you can see this one's a little bit more similar to the standing state, whereas ducking was kind of very simplistic. Standing is also, but this is actually has some movement logic. But you can still see like all the methods are very small and broken down. The state machine helps a lot with this because once you're in a certain state, you only have to deal with the logic in that state. So for walking, you got enabled. It starts playing the walk animation. It adjusts the horizontal speed. This is just a little helper that eases it. So instead of immediately your walk speed drops, it kind of slowly drops down on a curve. And then there's physics, which has the same check for coyote time expired. The nice thing about, actually no, I'll cover that later. That's the same thing that's being worked on from the standing state. Just checks if coyote time, basically checks if the user's off a cliff. And if it's off a cliff and the time is expired, then you get kicked out of being able to jump. You can no longer jump anymore. It also checks to see if neither the left or right buttons are held anymore, then just go back to the standing state. Same logic with jump press, whip press, that's all the same as when you're standing. Left held, it just moves you left based on its acceleration, or it'll mirror the animation if the right button is not held. It'll just continue. If the right button and left button are held, it'll just continue playing whatever animation was already playing. If left is held but right is not, then it will always face left. And then run held will enter the running state. Okay, so I'm going to cover the running state real quick since it's very similar to the walking state. Basically, you enter, you play the run animation, set the horizontal speed using some easing so it's not immediate increase in speed. Then this is basically exactly the same, except to check if the run button was released, go back into the walking state. You got jumping, you got whipping, and you've got the same moving left based on the acceleration. So that's the most progressive thing that I've done this week. There's other things I've been playing around with, like the idea of wall jumping in the game. I haven't completely ruled out whether or not I want wall jumping. There's just a question of how I want to implement it. I have it working in a couple respects. In my previous physics engine, I had it working where you could wall jump off of downward sloped walls. I haven't decided if that's the direction I want to go with it at this point, but we'll see. Oh wow, that's really screwed up. So I might put another update about that in next week's video. So that sums up my work on what I did for breaking down the standing state. Now I'm going to switch gears and look at that coyote time thing that I mentioned earlier, aka falling off a cliff and still being able to jump off for a certain short amount of time. To understand that, first you're going to have to understand how I work with services in my engine. So I've already showed off the concept of states, but now there's also these other things called services. These are not actually monobehavior components if you're familiar with Unity. These are just simple classes and scripts that get attached to the root class, just for shared logic that doesn't have to live on a component level. There was a lot of times where I wanted multiple components to share common logic, but at the same time, it made sense for that common logic not to live on either specific one of the components. So that's where the services come in. So if I use this one in particular, coyote time, this is another thing I split up when I split out the standing, ducking, walking, and running states. Before, all this coyote time logic was living in this single standing class. But once I broke it out into 3 separate states, I wanted to maintain that timeout that you could jump off even if the state happened to change. So if you go here, first let's actually bump up the coyote time. So you'll be able to see, let's make this like 3 seconds, something insane, so you can see how long I'm able to jump off once I fall off the cliff. So you'll be able to see that as soon as I walk off the edge, I'll still be able to jump for a short second, like that. Or even though I'm off the edge, I'm clearly off the edge, I'm still able to jump for a delay. So I can adjust that amount of time to kind of to my liking, but it's all defined in a single place. So if I walk off the edge and go from like a walking state and quickly go to a standing state, it still knows what time, like it's not tied to a single state. It still knows what time I walked off the edge at. So I can just walk off. Okay. Shorter into standing state. So if you notice, I'll walk off and then go into a standing state real quick. You'll see it by the animation. And then I'm still able to jump. So you can see it goes into the standing state, but then it still allows me to jump after the fact. So all of these states use this service called coyote time. Here, root.get the component is to get actual components. Root.use is to use existing services. So here, each one of these uses coyote time, and in their physics step, they check to see if coyote time expired, at which point it dumps you back into the jumping state. So you can see that they all have that in their physics step, the exact same check, but the logic for that lives elsewhere. So I'll show you. So as you can see, it was also defined in the root class so that they can all use it. So I'll show you this coyote time service, which is very simple, as you can see. So coyote time is the service. It just has its quick constructor, which C# requires, so it's typically empty. And then these are the important bits. So In this listen, it's listening for a floor stay collision, at which point it tracks when the last time this object had ground. So if you go here, you can see in subscribe it has coyote time.listen. So it's basically just listening to whatever events coyote time needs to listen to. In this case, the floor collision. And it uses that last ground at value to basically check to see if this object does not have floor and the time, since the last time it was on the ground is less than the coyote time, then that's expired. So that time is too late. You can no longer jump, at which point all of these dump back into the jumping state. So yeah, that's an example of one of the services. I just found there was a lot of logic that didn't really necessarily need to live in any of these states, but was better off just in a common class where it could have its own logic in a single spot. There's a lot of other uses for services that I've done. I can cover more in the future, but at this point, that's a nice intro to states and services, which is how I write basically all of my code. So you'll need to know that for upcoming videos if I keep posting these devlogs. I'm hoping the next one I'm probably going to try to do shorter but more frequent updates. So the next one should hopefully be in the next couple weeks. I also just had a kid right now, so honestly, it just depends on whatever time I get. So until next time, I'll see you later.